Hi, welcome to the very first in-person friendly tech chat.
Yes, we're sitting now here in Amsterdam, and a beautiful Nemo museum is in our background. And we want to talk about testing machine learning applications where some machine learning is involved. And the background for this story is I was involved in a small event where people were asking how to test their project, which test strategy to take, and many of them they were doing something with machine learning. And I figured out that I don't have much experience with that. I just only know that there is an extra complexity because of the non-determinism of the trained models. And I wanted to ask someone who knows a little bit more than me, namely Bart, to tell about this.
Yeah, so my background in this is at Bol.com. I worked for like 1.5 years as an engineer in the data science department. And this particular problem of quality assurance in a data science environment where you have non-deterministic models was one of the particular things I focused on. And what I found at Bol.com is that the modeling part, the learning part of machine systems that are driven by AI and data science models is a relatively small part complexity-wise. There is, of course, a very own science to optimizing a model through getting the right kind of data and getting the right kinds of models. But usually data is more important. But there's a whole context that you need to build before those models are actually providing value as a solution for a company. And getting this context right, where traditional software engineering approaches are really valuable. So I'm not quite sure if that maps to the particular questions that you got.
Let's talk general. From your experience, what are the strategies that you would expect? Like, say, if I am a backend developer, and I am getting involved in some project where lots of new data scientists just fresh out of universities are crunching cool models, where to look for? It will be different from normal approaches? How to isolate this non-determinism? You're saying that it's not a very big part of the whole equation, which I would assume, especially as in the bigger organizations with lots of data streams, with lots of problems just in cleaning the data and getting it right, exactly. Much more than actually training the model. But did you have any experience where the model did play a big role there?
Yeah, so that last particular question, I'm gonna think of that while we're talking. But some of the recommendations from what we experienced, what you want to do is that you want to make it as easy as possible to experiment with different models. So that road from idea to serving value with a model, you want to make that as smooth as possible. And so that includes things like standard setups for doing ETL or ELT and having maybe some sort of standard framework for serving a model to the rest of the software landscape that needs to use this new valuable model. And by now I forgot what the particular question was that I was supposed to be thinking about.
So what you're saying is basically that to have a certain level of quality, you want to have standardized pieces and have a simple way to swap like your model to check that it still fits. Would you ever consider testing the whole model and ETL, or would you always prefer to have them separately tested and evaluated? Can model have big enough influence on the holistic results to consider end-to-end test?
Yeah, so a big factor here I think is whether you're doing online learning or not, because I consider like on learning online learning to be one of those things that's kind of like continuous delivery, like all the way to production, where everyone who's doing machine learning wants to do online learning, but actually most are not doing it.
What is, for my knowledge, what is online learning?
So that with each interaction, you update your model. Like most systems don't really actually need it. And this is also one of the things, I'm digressing a little, obviously, but to deliver value, most problems don't need the latest and greatest of data science and machine learning. Like usually you can just get lots of value with fairly simple models, and that's probably where most projects should start. And to come back to the integration testing question, so that is where whether you're learning online or not really comes into play. Because if you're learning online, then the behavior of your system will change continuously. So then you almost need to test it, treat it as a black box. But if you basically deploy models one by one through their own pipeline, then you can just validate quality checks on those models and put that in your deployment pipeline and just stop it if it doesn't improve. So that's, I guess, where the difference is.
What you're saying is that with online models, you would be more inclined to look on this holistically, whereas if the models are offline, you can relatively easily test them in isolation. I'm here focusing on testing and quality, not necessarily the business result of the model. Is it improvement or not? But is it at all good to release to production?
Yeah, and that's an interesting difference, because of course is the business value improving? That's also the creation of the model. I mean, you have your test sets and you have your cost function, which are all which you use to, like, through machine learning, optimize that cost function. But there's way more that goes into actually delivering value, and that is because the way you design your cost function can be totally wrong. So that's where the value is in assessing the behavior of your system outside of the normal test iteration loop that you have for designing the model. All right, so that was our in-person talk on test strategy for machine systems involving machine learning and data science. Don't forget to leave a comment and tell me what horrible lies I've been spreading. Be sure to subscribe.
That's all it is about. Yes.
Particularly one of the things I focused on as an engineer in the data science department. And what I found is... Okay, let's start. All right.